Hey guys, how's it going? This is Abed Yuba. I'm your curator for today. Today we are looking at the November 2019 paper. So Maths Paper 1, November 2019. And without further ado, let's get right into it. So the first question says, express 460, so 2460 cubic centimeters in liters. So express this in liters. So whenever you're asked to change from one unit to another, you have to know the conversion factor. So there are two ways to write the conversion factor, and the easiest way is to write it as a ratio. So you should know that 1000 cubic centimeters is to 1 liter. So you're expected to know this. This one, it's a basic conversion factor. So you're expected to know this. And what you want is 2460 cubic centimeters in liters. So what is it? Obviously, this one is going to be more just because we are dealing with when the cubic centimeters increase, the liters increase as well. So we are dealing with direct proportion. So these are directly related. So that's why we just compare this and then we see this one is more. So we say this one should be more as well. So if it's more from primary school, we know that we say big number at the top. So big number at the top, this one, you convert it into a fraction. So big number at the top, multiply by 1 liter, and these ones, they cancel, obviously, and you're left with liters. And you have to say 1000 into 1000, 1 into 2460, you get 2. And you're left with 460. Then you add a 0 again, then you get 4. Then you're left with 600. Then you add a 0 again, then you get 6. So you get this one, and don't forget to put your units, of course. So this one in liters. So the first thing that we do is to identify the conversion factor. For our case, it was 1000 cubic centimeters is to 1 liter. And you just use simple proportion. Where it's more, it means a bigger number at the top, the part where you convert into a fraction. So that's it. For B part, it's a little tricky. I want you to really be careful. So most people, they probably know the conversion from 1 hectare. Most students, they know the conversion of 1 hectare into cubic meters. So that's what that's 1 hectare into square meters. They don't know for square kilometers. You need for square kilometers. So how do you convert this? So how do you do that? You have 10,000, and the linear conversion factor from meters to kilometers is what? It's 1 over 1000 kilometers per meter. This one is the linear conversion factor. But here you want to convert to an area. So if you want to convert to an area, you have to square as well. So you get 10,000. I'll include this in your working. Of course, I'm just doing this to save space. So that's why I'm doing it like this. But you should include this in your conversion. So over square meters here, square meters cancel, square meters cancel. Then 0, 0, 0, 0. We just canceled 4 zeros here. So we're also going to cancel 4 zeros. And we're left with 100. 1 by 100, you get 0.01. So 1 hectare is to 0.01 kilometers. Now, why is this important, this conversion? Because you're asked to express 1 hectare as a percentage of 0.25 square kilometers. So 1 hectare divided by 0.25 kilometer squared, multiply by 100%. Don't forget to put the 100%. It's kind of trivial, but you have to put this, okay? And here we have discovered that 1 hectare is equal to 0.01 square kilometers. So it's 0.01 square kilometers divided by 0.25 square kilometers multiplied by 100%. So here you multiply so that you can get rid of the decimal. That's normally the way that we go about it. And here you get 25. And you multiply this by 100%. And 25 into 25 you get 1. Into 100 you get 4. So your answer is 4%. Like this. So just a recap, 1 hectare, you have to match them. You have to match the units. So it's easier for you to match the hectare into square kilometers. But the problem was that most students, they know the conversion for square meters, and you should know one conversion at most. Especially if you're having trouble memorizing, memorize this, and then you can always use the conversion for kilometers to meters. And don't forget to square. And when you square this, remember this number is squared as well. So that's why we wrote 1 million here. 1000 squared, you get 1 million. It means you had 3 zeros. Now you have 6 zeros. So you do that, and then at the end of the day, you have to multiply by 100%. 100% is the conversion to a fraction to a percentage. So you have to write 100%. And that's it for our question 1. Question 2 says evaluate -8 to the power 3/2. So how do you do this? We actually did a similar question in the 2020 paper, the June 2020 paper. And here, this one was supposed to be, let me just correct this real quick. This one was supposed to be 2/3. So here we say that our denominator comes here, and then our numerator is the power, and then you just replace. So in a -8, the cube root of -8, it's -2. Why? -2 by -2 by -2. You get what? Negative and negative, you get positive. Then you get negative from this one. That's why you get -8. So the cube root must be -2. And another way to do it is to realize that whenever you have a negative and you are rooting it by an odd number, it means that the negative is retained. It comes back. So the negative is retained, it comes back. And when it comes back, you just put it there, and then you just say cube root of the number. The number in this case is 8, and the cube root is 2. So -2 to the power 2, what do you get? You get 4. -2 by -2, you get 4. So, and then this one, I really want you to listen very carefully, because surds can be very tricky. These are called surds. So they can be very tricky. The first thing that I want you to realize, because we have to combine them in this form, where this and these, they're integers. So the first thing that I want you to do is to use your cross diagram. So the cross diagram makes you realize your factors. You want to know what exactly constitutes 147. So you just guess, usually 3 I think it gets in. So 3 into 14, you get 4. Remainder 2. 3 into 27, you get what? You get 9. Then 49, 7. 7 into this, you get 7. 7 into this, you get 1. And notice the numbers that we're using here in our cross diagram. These numbers are what? Are prime numbers. And there's a reason we are doing this, and you know that shortly. So we use this method in HCF, finding HCF and finding LCM. LCM, exactly. So finding highest common factor and finding lowest common multiple, we use this method. So just repurpose it for this. Always break down your numbers and see what comes. So this one, it's an even number at the end. So whenever you have an even number, it means that 2 is definitely a factor. So 2 into 10, it's 5. Into 8, it's what? It's 4. And then 2 again, you get 27 here. Then 3 into 27, you get 9. 3 into 3 into 9, you get 3. 3 into 3, you get 1. After doing this, now you can come back and then express your surds differently. Equal to. So 147, now include all this. Don't write them aside or anything like that. They want to see, the examiner wants to see your working. So you have to include it. So here we get 3 by 7 to the power 2. So you pair up numbers. You see why we're pairing up numbers. that are multiplying there. So 108, it's 2 to the power 2 times, yeah, you guessed it, 3 to the power 3 times 3. There's another excess 3 here. So here, if you have a square root and you have multiples, then you can actually break down this into 2. And here you have also the same thing. Let me just rub this part so that we are consistent with our method. So multiply by, the dot means multiplied by. So 3 to the power 2 multiplied by 3 here. This one was 3. And what you get here is this one is squared, so the square root must be just the number. So it's 7. 7 square root of 3 plus this one, it's don't write 4 here because it's 2 squared, which is 4, square root of 4, which is 2. And this one is 3. And this one is supposed to be under a square root. So here we get 7 square root of 3 plus 6 square root of 3. Then here, they are the same. So you're essentially adding 7 square roots of 3. So you can imagine you have square roots of 3, you have 7 of them. Here you have 6 of them. So what do you get? You get 13 square roots of 3. So this would be your answer. So the first thing that we did was to use this lowest common multiple, highest common factor method, the T diagram, and we have to express these numbers as a product of the prime numbers, the prime factors. So the prime factors are these ones, and then we squared them so that we can identify those that we can remove from the square root. So we identified them and we multiplied them, and at the end of the day we had this. And whenever you're told to express in terms of your answer in the form m square root of n, it means that it should be possible. So if you're having some struggle expressing it under the same square root such that you can add or subtract, then that means that you're doing something wrong. You just have to look intently and then you figure out your answer. So this is it. So you get 13 square root of 3. Let's move to question 3. Question 3 says solve this simultaneous equation. So in your this one I'm calling it 1, this one I'm calling it 2, right? And then the method that I want you to use almost always, wherever it's possible, is elimination method. It's the fastest. And when you can't use elimination method, use substitution method. Don't use matrix method, and don't use graphical analysis method for paper 1, especially when you're not told to use a specific method. So for this one, we'll use elimination method. But then the problem now is that the coefficients for the variable, they have to match. So you have 3 and 5, they don't match. Here you have -1 and -2, they don't match again. And the easiest that you can match are the coefficients of y. So how do you do that? This is 2 and this is 1. So multiply this one by 2. So you can say 1 multiplied by 2, and you are supposed to multiply throughout. So you get 6x minus 2y equal to 4. And here, this one is just retained as it is because you're multiplying it by 1. If you want, you can even say 2 by 1. It's still okay. So after this now, let me just remove this part. So after this now, you have matched your coefficients for y. Your signs here, they are the same. If your signs are the same, you subtract. That's how you get rid of one variable there. If your signs are different, add. So here you get 6x minus 5x, you get x, minus 2y minus, so you get plus, minus 2y plus 2y, you get 0. If you want, you can write plus 0 here, it's still okay. And you get 4. So it means that x must be equal to 4. Then you underline your answer. This is a simultaneous equation. These are simultaneous equations. So what we do is we have to find the value of y as well. So you choose the equation that's easiest. So equation that's easiest was the first one. because it already has y in it. So you say 3x minus y equal to 2, then y when it goes to this side equal to 3x minus 2 when it goes to that side. So 3, or x is 4 minus 2, then you get 12 minus 2. So at the end of the day you get y equal to 10. So that's it. So you have to match the coefficients, and you have to identify here the subtracting where you want to eliminate. So you have to they're the same sign, so you have to subtract. If they were different signs, then you would have had to add. Let's quickly move to question 4. It's given that q equal to -6, r equal to -1, t equal to 2, and you're asked to compute the value of qr by t. So our q is -6, our r is -1, our t is 2. So -6, negative and negative, you get positive. So you get at the end of the day 3. There's this one. It was taught to me by my class teacher in O-level. It's called the magic square. And don't rely on it too much. When you work out enough of these questions, then it becomes easy for you, directed numbers, multiplying them. But essentially, when you have negative and negative, you get positive. Negative, negative, you get positive. So that's the essence of the magic square. So that's it, and you get 3. 3 is your answer. And let's move quickly to the second part. The B part says compute or evaluate qt minus r. So our q is -6, our t is equal to 2, our r is -1, like this. Always use brackets when you're substituting for anything, because it's safer that way. You don't forget any signs. So it brings clarity to your work. It brings clarity to your work. So here you get -12, negative and negative, you get positive. So now you get this. If you want, you can also put equal signs there so that your work is very neat, and you get -11. And that's it. Just underline your answer. So always remember to use brackets. Here we have q minus r to the power t. So here I'm actually going to use bigger brackets so that it's clear a little bit. So here you get -6 minus r is what? Okay, so this one is supposed to be plus. So q plus r to the power t. So -6 plus -1, like this, to the power t. T is equal to 2. Then here you get, we can use ordinary brackets now because we want to eliminate the stuff that's inside. So you get -6 plus and minus, you get minus power 2, then you get -7 power 2. Always use brackets. So -7 power 2, you get 49. If you don't use brackets, what will happen is that here you think it's -7 to the power 2, and then you write -49. This is wrong. This is wrong. So this one, it's not equal to this one. So this is wrong. So just use brackets whenever possible. Just use brackets. Let's move to question 5. Question 5 says, state the rotational symmetry of a rhombus. Usually they actually ask for polygons, regular polygons. That means heptagon, pentagon, square, and all that. And usually for those, the rotational symmetry, the order of rotational symmetry, it's equal to the number of sides. But then for rhombus now, it's a little bit tricky. If you want to determine the order of symmetry of a rhombus, you have to rotate it. So you have to rotate it through 360. So you go 360, and then the number of times that it returns to its position, that's your rotational symmetry. But then the problem that most students make is that they draw the rhombus like this, of which here it will be hard for you to see the order of rotational symmetry there. So what you do is draw it like this. So here you can see that if you rotate it again, when this peak goes to that peak, then it's going to be another order. So you have 2 orders. So it will be order 2. So you have order 2. So the rotational symmetry for this, it's supposed to be 2. Okay. So rotational symmetry here, you get 2. So it's the number of times that the shape retains the shape when you rotate it, the number of times that it returns to its original state. So this one, if you rotate it again, when this one goes to this peak over a 360 cycle, the number of times that it returns to the place where it was, that's the order of rotational symmetry. So in our case, the rotational symmetry is what? It's 2. 4 of the interior angles of a 12-sided polygon are each x degrees. So you have 4x in all, because you have 4 sides that are x degrees. Then the other sides, how many would there be? There will be 8 sides. So 8 sides, they're each 2x, the remaining. But then you have to know what's the total for interior angles of a 12-sided polygon. The total would be what? The total is supposed to be n minus 2 by 180, where n is the number of sides. So n is equal to 12 for our case. So 12 minus 2 by 180, like this. And here you get 4x, here you get 16x, here you get 10 multiplied by 180, here you get 20x equal to 1800. You divide both sides by 20. After that, you get x equal to, cancel this one here, 20 over 180, you get 90 degrees. So that's it for our question 5b, and in the next video we'll look at question 6 to 10. So thanks so much for watching. Make sure you subscribe and like this video and share with your friends. Cheers.